In lesson 5.2, we talked about medians and altitudes. So the first topic was medians. A median is a line segment that connects a vertex of a triangle to the midpoint of the opposite side. So we're going to need the midpoint formula to find the point in the opposite side. Typically, at least if we're on a coordinate plane. The three medians of a triangle intersect at the centroid. And the centroid, we have the special relationship that it creates two segments, basically, of our median, where the larger segment is equal to 2/3 the length of the median, and the smaller segment is equal to 1/3 the length of the median. So I have a couple of theorems, or a couple of little formulas. The big part equals 2/3 times the median, the whole length. And the small part that's created is equal to 1/3 times the median. And then together, the big piece plus the small piece is equal to the whole median. So those are things that we can use to help us find parts of the medians, or the median itself. In the example, it says we have triangle ABC. U is the centroid, so that means that we've intersected the medians of our triangle, and that BU is, here's BU right here, that BU is 16, and we want to find UK, which is going to be our little blue segment here. We want to know what that is, and what BK is, which is the whole median. So since I'm given information about the bigger portion of the segment, I'm actually going to start with that formula that we have, because I can use that to find other parts that I need. So I have the big piece, which is 16. The big piece is equal to 2/3 the median. That's the one I'm going to start with. And we know that the big piece is 16. And that allows us to solve for the median, which is segment BK. Now to do this, we actually want to get BK by itself, we want to divide by 2/3. That's where we keep it, change it, flip it. So we're actually going to end up multiplying by the reciprocal of that, which is 3/2 on both sides. And so on the right side, the 3's and the 2's will reduce, and we're left with BK. And on the left side, 2 goes into 16 8 times, and that leaves us with 3 times 8, which is 24. So I get that BK is 24. Well, on our figure, if 24 is BK, that's the entire length. To find the length of the smaller side, I would just have to subtract, because the median minus the large portion is equal to the small portion. So I'm going to use that idea that the big piece plus the small piece is equal to the median. The big piece was 16. I still want to know what that small piece is, which is UK. So I'll just go ahead and put the UK there. And then the median we found actually was 24. So all I do is take and subtract 16 from both sides, and I should get 8. So the median is 24, and the small portion is 8. Okay, then you have those problems 1 through 12 to work on that worksheet. On this next section, 5.2, we talked about altitude. Altitude is actually related to the height of the segment and goes from the vertex and is perpendicular to the opposite side. It's not necessarily a perpendicular bisector, but does have to be perpendicular. And the intersection of the altitudes, which there are 3 of them on a triangle, is what's called the orthocenter. So for the example, we're going to plot those points on our coordinate plane and make our triangle. So I have, let's see, 1, 3. I have 7, 7. And I have 9, 3. And we want to draw in our segments. Let's try that again. Okay, we're going to forget our segment. I'll just draw that guy in. Ideally, we're going to use a straight edge for this because you can see that my picture is not going to be the best. Okay. And then I want to find the coordinates of the orthocenter. Well, I need my altitudes. And so anytime I have either a horizontal or vertical side, I want to make an altitude to that. So I'm going to go from the very top, and you can see already I'm having some difficulty because my picture was not good. I have to go from that vertex down. So that's going to be right in here, and that's one altitude. And then my other one has to be from, let's say I'm going to go from point A here. This is actually point A, and this was B, and this was C. So let's go from vertex A to segment BC. To do that, I actually need to start with what's the slope of BC. So I want the slope of BC. And I'm just going to use rise over run to do that. So if I look at this and I count from point B to C, I'm going to go down 4 and to the right 2. So my slope, down 4 and to the right 2, BC is going to have a slope of -2. Now, I want a slope that's going to be perpendicular to that one. So I want the opposite reciprocal slope. And I'll write the perpendicular to BC. The opposite meaning is going to be positive, and reciprocal means it's going to be 1/2. The easiest way to do this is when you take a look at your picture here, whatever vertex you're going to go from, start with, you're going to take the slope, and that's going to send you in the direction of BC, hopefully. My slope I want is 1 over 2, so I'm going to go up 1 and over 2, and I actually want to do that until I intersect BC. So again, up 1 over 2, and I'm going to continue to do that until I get to a point that's either on BC, or it's at least on the other side. And now I can draw my line going through there, and I'm going to have another perpendicular segment. And so now you should be able to see where that intersection is. Looks like we have an intersection about there. So that's going to be my orthocenter. And my orthocenter is at point, looks like 7, 6. You only need 2 altitudes in order to find the orthocenter because the third one automatically should go through the intersection. Okay, you also have a couple of problems there. You're going to need some graph paper to graph, and you're going to practice finding that orthocenter using the given vertices.